Okay, so let's take a look at a couple of problems here real quick and see how we're doing. This is the mid-chapter review. I think we'll just look at the first maybe four questions. So when you're looking for any kind of angle that's like a pi over 12, there's a bunch of different ways to deal with it. But the way that I personally would like to do it is honor the fact that the sine is an odd function. And so I personally like to go ahead and remove that negative to the front and then stop and think about what are two angles that would make this work? And I like 3/12 plus 4/12, or in other words, pi over 3 plus pi over 4. So if I'm asking to find the sine of pi over 3 plus pi over 4, then I'm going to use the sum and difference identity. And remember, the sum and difference identity for the sine is that the sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, where alpha in this case would be pi over 3 and beta is pi over 4. So I have the sine of pi over 3 times the cosine of pi over 4 plus the cosine of pi over 3 and the sine of pi over 4. Now, the nice thing is if we know our trig identities and our unit circle pieces, we should know that the sine of pi over 3 is root 3 over 2. Any kind of pi over 4 is root 2 over 2. A cosine is a half, and a sine is root 2 over 2. And we have this familiar story of a root 6 and a root 2 all over 4. So that is negative, and that is a root 6 plus root 2 over 4. Now, some of you I did notice actually chose to attack this using a half angle identity. And if you did use a half angle identity, that's totally fine as well. I'm not going to choose to do that at this moment in time, just because I don't have enough room on my paper to do that. So I'm going to stop right there. So on the second one, what I'm going to do is I'm going to look at this as the cotangent of 5 pi over 4 cut in half. On the pi over 8s, I have no choice but to use half angle identities. And so I was grabbing my card because I want to use this half angle tangent identity. And since I'm going to be flipping it over, I personally like this version right here. And so notice that I'm going to flip that identity over and I'm going to plug in 5 pi over 4 in both cases. And I know that 5 pi over 4 is in the third quadrant where both of these numbers, actually, that's funny, I forgot to write the cosine there, are negative. So I've got the cosine of 5 pi over 4 is negative root 2 over 2, and the sine is also negative root 2 over 2. So we do want to do a little bit of cleanup. I'm going to multiply at the top and bottom by, say, negative 2, and that's going to be negative 2 plus root 2 over negative root 2. Actually, positive root 2, excuse me. And then one last little step is I want to clean it up. And as it turns out, root 2 divided by root 2 is 1. And 2 divided by root 2 is root 2. So I got negative root 2 plus 1. And we're done. Okay. Now, there's a few other ways that you could have attacked that, but that's what I feel like is a pretty good way to go. Now, on number 3, the big key here is we're saying, let's try to do that without a calculator or without a triangle. And so what I'm going to start with is the idea that sine squared plus cosine squared is always 1. So I would know that sine squared plus this cosine right here squared, which is 9/16, would be 1. Now, clearly, if we subtracted 9/16 from both sides, we're going to get 7/16. And so the sine of beta would be plus or minus the square root of 7 over 4. But this problem didn't actually ask me for the sine, it asked me for a cosecant. And that means the cosecant would be plus or minus 4 over root 7, which of course we could say as 4 roots of 7 over 7. And again, we're done. Okay, now coming over here to this last one for this particular video. This is an identity for the sine, so I'm being a little bit sneaky, but I'm telling you that the sine of beta is 12/13. So what I think I would like to use for this particular problem is, I think I might just go ahead and go this way and say that the sine squared plus the cosine squared is 1. And I know that the sine squared is going to be 144 over 169, which is going to make the cosine squared, I guess that's 25 over 169, which makes the cosine plus or minus 5/13, because keep in mind I have to take a square root. Now, that may seem like I did kind of a strange path to get to this value because I actually went after a cosine and the problem is asking me for a tangent. But you want to remember that a tangent is a sine over a cosine, but we already know that the sine is 12/13 and the cosine is plus or minus 5/13. And so we can actually just simplify that down and say that the tangent is 12/5. Now, the reality is you could have also used cotangent squared plus 1 is cosecant squared, and that would have worked as well. I just chose to go that particular version. So hopefully that was helpful, and I will see you back in class later. Bye-bye.